Hello all, my name is Richard Nugent. I am an economist and the lead developer of the HEC FDA program at HEC. This series of videos serves as an introduction to the derivation of uncertainty surrounding the stage-damage relationship. In this video, we will review the stage-damage relationship and the sources of uncertainty. Let's refresh our memories about the stage-damage relationship. This is the relationship between the economic cost resulting from flood damages and the elevation of flood inundation or stage for a given plan, year, stream, damage reach, and damage category. Our task in this series of videos is to study what goes into identifying the spread of damages for a given stage. Observe that the dispersion of damages about the median, as measured by the standard deviation, increases with increasing stage. So the stage damage function looks like a fan spreading out, representing the bounds of damage within which we are relatively confident the true stage damage relationship lies. The following attributes are some of the sources of uncertainty of the residential stage damage curve or function that results in dispersion or spread uncertainty of the level of damages for a given stage of flooding. The number of structures by category and construction type, the structure values by building type and use, content values by building type and use, first floor elevation of a structure, damage as a percent of value for structure and contents for a range of flood depths, and the link between structures and a range of flood depths. We're going to look at each of these in more detail in a later video. Typically, for common non-residential structures, the distinction between residential and non-residential damage is valuation by type and percent damage by depth. Non-residential stage damage curves are subject to the same sources of uncertainty. Unique structures may require site-specific data, that is, a general depth damage function may not be applicable to a unique structure. An example of such a structure might be a marine terminal. To my knowledge, no depth damage function exists that is applicable to a marine terminal. Smart planning is a consideration. We work under the 3x3x3 rules. So we're going to want to focus resources on elements that assist more in informing decisions in the planning process. If a marine terminal is in the study area, has significant exposure, and there's a history of significant damages, perhaps it makes sense to focus resources on collecting site-specific data for the terminal. Let's take a look at the links from water to structure and content value to damage. The distribution of first floor elevations determines a distribution of depth of water above the first floor elevation for a given water surface elevation. The distribution of depth of water above the first floor translates into a distribution of percent of structure value and content value damaged, which are each linked with the respective structure and content value distributions to produce a distribution of structure damage and content damage for a given water surface elevation. Summing the two distributions, we get the stage damage relationship as shown in the image at the bottom of this slide, which is the stage damage relationship overlaid with the distribution of damages for a given stage. And we just talked about several attributes and how their distributions feed into the dispersion of the stage damage relationship. But how do we specify the distributions of the individual attributes? There are several options, including looking at the accuracy of measuring techniques, the range of values from a study site, getting data from a similar site, using national data as a generic representation, drawing from expert judgment or the elicitation option, or performing sensitivity analysis. Whichever method you choose, You should have a good reason for choosing that method and be prepared to motivate that reason. If you have any questions, please feel free to email me, Richard Nugent, or post your questions to the Discourse discussion board. Thank you.